Okay, so in the previous session, we have seen so how we have the data is going to be organized into Hadoop cluster. I have teach you a basic
Yeah.
Hadoop architecture, right? How your data is parsed or the parsed in a Hadoop cluster, right? So I
Yeah.
just want to tell you,
Yes.
so what will be the Hadoop developer role? Actually, what you have to do and what are the Hadoop components, or you can say Hadoop stack.
Okay.
Okay, so
Okay. Okay.
till now we are habituated for every project, so it is in client and server architecture. That is, we have a client, right? We have a client, and so there is a
Uh-huh.
server. So client will be connected to the server, and we have a database. Correct. So this is till today we are
Yeah.
all habituated to a architecture, three-tier architecture, right? So that is where
Yeah.
a client is going to connect to the server, and database connected to the server. So the client request will be processed to the server. If the data will be given to the server, and the program execution can be done in the server side. Correct. So this is what we have,
Okay.
what we know till today. So you wrote some normalizations. We have different ways. You're using the RDBMS. You're using the web server tools to configure the server, client application to write a client application program, right? So this is what you did as your project. Correct. So now
Yeah.
when a client is implementing Hadoop, means don't think that he's completely migrating from his existing infrastructure. That it. So a client is implementing Hadoop means the Hadoop is having an added or extra infrastructure to his current architecture. Right? He's
Okay.
having his three direct architecture as it is. And apart from that, when the client is going to implement the Hadoop, so he has to configure some Hadoop cluster. So where we have a name node and some set of data nodes, right? So it's a data
Yeah.
node one. Like this, we'll have the Hadoop cluster, right? So how many data nodes we're having? Four data nodes, and one name node is configured. And as usual, it's a client, and it's a server, and database, right? So these are the data node one, data node two, data node three. So multiple data nodes, right? So we have a Hadoop architecture like this. Now all the data nodes are connected to a name node. Correct. So this is what we have seen, and Hadoop cluster like this will have. Okay. Now uh, we have in a Hadoop cluster we have configured Hadoop, right? So in every data node we have SDFS is available. Correct. So in each
Yeah.
data node we have SDFS. So whenever you have installed a Hadoop means we have to start SDFS. Right. So in each data node we'll have a SDFS is a file system where we are going to store the data, right? We have
Yeah.
the SDFS. Now I want to process some data, right? So your client, right, every day is getting the data to his production database. Okay, consider
Okay.
every day is getting 500 GB of data into his production database, right? 500 GB data is getting to the production database. Now he is unable to analyze the data because it's 2 days it becomes 1 TB. So in a month the total data becomes 15 terabytes of data, right? Which is not at all possible to analyze with a database, right? It is possible, but you have to wait a lot of time to querying as well as generating the reports. Correct.
Yeah.
So database is
Yeah.
limited. Okay, so when he's having this much of data is going to be generated every day, so because he is unable to perform apply the analytics on the database itself, now he will move the data to the Hadoop cluster, right? Because it's the big data now. So now from the database. Whatever the data you're having in the database, we have a table. In a table we have some data is available. So now whatever the data comes on every day, the day wise I want to import the data to the Hadoop cluster. So that, so now the data will be imported to the Hadoop cluster.
Okay.
Okay, so now here we use a component called Scoop. Okay, it's a Hadoop components, and Scoop is a one of the Hadoop component. So what Scoop will do, Scoop is used to perform the import and export the data, right? What it will do, it will perform
Import
import or exporting the data between RDBMS to
Hadoop cluster.
Hadoop cluster, right? So you can perform both import as well as you can perform both export. So Scoop is a one component which performs the data import and export between the production database to the Hadoop cluster. Got it now?
Okay.
What will Scoop do now? So get the data to the cluster, process it, and again if you want to store the data, then export back it to the database. Right. And
Okay.
next one, not all the clients will have the database. Suppose you take YouTube, Facebook, Twitter, right? So we don't see that they will store the data into the database because they have a bulk amount of data. They'll store the data into the database, but so most of the time, so the maximum amount of the data is traveled through the servers, right? So what they will do now, they will maintain some network attached storages to store the data. What we call it as NAS. Okay, it's a network attached
Why
storage.
can't we store them in database?
What, Prithvi?
Why can't they store that in database? Why do you need NAS?
Because how much the data they are going to generate? See YouTube, right? How much is the data they are going to generate in a day? Correct. So it's a bulk amount
Yeah.
of data. So the bulk amount
Okay.
of data processing cannot be done because you cannot able to store that much of data into the database. It's because it's a limited we have. Correct.
We can't increase the capacity of database?
You can increase, but the processing speed,
Okay.
right? Well, that is the advantage with the Hadoop, right? So how much the data you are going to process, right? We cannot work with the bulk amount of data with an RDBMS.
Okay.
Okay, right? See here, if it is an RDBMS you are using, right? RDBMS is an interactive and batch processing, right? So the
Yeah.
Hadoop, it's a batch processing. In the RDBMS, it's a read and write many times. Here, we can perform write once and read many times. So here the
Okay.
Hadoop is a dynamic schema. We won't specify initially the design of the data, right? So here, but here it's an integrity because here it's unstructured. So there is a low, right? Low integrity, right? Scaling is it's
Yeah.
a linear scaling, it's a non-linear.
Okay.
See now how much the data they are going to generate. See, in every 1 minute, this is the data in 1 minute data. Okay, so in 1 minute in YouTube there are 600 videos that they are going to upload, right?
Okay.
So there are 4 lakhs of Skype calling, 2 millions of Google search queries, 200 millions of emails, 7 lakh updates, right? So the people in US are spending 3 lakhs of US dollars on every minute in online shopping. Okay, see now,
Okay.
so how much data it is? So it's not at all possible for them to store the data into the database. Correct? So now the data will be available in a
Yeah.
NAS. It's a network attached to storages. Right? So then what we'll do now, we'll configure an agent. Okay, agent is a program. So we'll configure an agent. So this agent resides in a server, and this agent will store the data, collect the data from the server. Okay, so this agent
Okay.
resides in a server. When the data is traveling through the server, this agent collects the data and sends the data into the Hadoop cluster, right? So we use a component called Flume. Okay,
Why do we need Flume? We already have Scoop, right?
Scoop works with
Importing and
only,
exporting.
yeah, Scoop works with only the database. Okay, so if your data
Okay.
is, if your data is available in the servers, so we cannot able to use Scoop, so we have to use Flume. Flume is a one
Okay.
component which resides in a server, and when the data is coming, then this agent will collect the data from the servers and sends or sync the data into the Hadoop cluster. Got it
Okay.
now? The component is what? What is the name of the component? Flume.
Team.
Right. So these are all the small components, Prithvi. So don't think that these are the big programming tools. Suppose if you type Scoop,
Okay.
only will get these three things. Sorry, five commands.
Okay.
See,
Okay. Okay.
it's very easy. Okay. So again, don't think so. We have to go with all these things. So these are all the small documents. See, only these five commands are available. That's it, and it's easy. Okay, so the same way Flume is a small documentation, right? So which collects the data from the server and syncs the data into the cluster, right? Now, so how we are getting the, how we are collecting the data from your three-tier architecture to Hadoop cluster? Got it now?
Okay.
Right, so every
Yeah.
client will have, either they have the data in a database, either they have a database in server. So now wherever the data you are having, so we have some solution to collect the data, right? Otherwise,
Okay.
so we can able to configure an FTP. Okay, what we'll do, we can able to configure an FTP, right? So with this FTP, like WinSCP or some kind of tools, right, which are used to upload the data into the Hadoop cluster. So this is one way. Okay,
What
so
is Windows here?
it's a file transfer protocol, FTP file system, right? So we'll upload the files into the cloud, right? How we are going to upload? The same way we can upload some files from any location to the Hadoop cluster.
Okay.
Okay, it's a
Okay.
WinSCP. It's a, like, see, it's kind of tools we have something. It, see, now we have a WinSCP. It's a tool. It's an application,
Okay.
right? So we'll specify the cluster host name.
Similar to Putty?
Yeah, similar to Putty, correct. Now it's here we have an FTP protocol. So then we'll connect it and we'll send the file. Which file you want to send it? We can send it to the SDFS.
Okay.
Okay, so like this we'll use to store the data, to process the data into WinSCP. Okay, and then suppose what we did, we have configured Hadoop, right? So we can able to copy a file from the local file system, right? Means from the operating system where you have installed the Hadoop. So from operating system means either you are having Windows or the Linux. From your operating system also to, you can able to collect the data and sends the data into the Hadoop cluster, right? So here it's a local file system and this is a SDFS file system. Then we can able to copy the files from local to SDFS as well as SDFS to local file system.
Okay.
Okay, so these are the different ways we are getting the data, right? Now finally, either it's a Scoop or a Flume or FTP, or you are copying the files to the local file system. What we are doing now, we are making the data available in Hadoop cluster. That is, we are making the data available in SDFS, which is our input data to process the data, correct? After
Yeah.
that, once the data is available in SDFS, now what we are going to do? We are going to process the data. We are going to apply the analytics, or we are going to write the jobs. So now you can use here Hive or Peak or Java, right? So which we call we can use MapReduce or Yarn. Okay, so which is used to process the input data, right? So suppose we have
Yeah.
employee data is available in employee database. We have imported the data into the Hadoop cluster. Then I'll write some queries in Hive or some programs in Peak or some programs in Java, so that I can able to analyze the data. I can able to generate a report. Correct. Now, so once the data is available in
Okay.
SDFS, they are going to be processed. Right. After passing the data, what we have to do? Right. So you cannot give the output
Analyze.
directly to the client. The analyzing part we will write in Hive or Pig or Java. Right. That's a processing. We are doing that. Now after that, how do you give the report back, result back to your client? So did you give output of the program directly? No. We have
No,
to generate
spool.
uh, we have to generate the reports, visualizations, reporting tools, right? You know what is the
Mm.
reporting tools?
Yeah.
Right. See, so now after that we have visualizations, right? So like we use here different visualizations, right? That is, you can use W or PQ, or we have some reports doing tools like Pentaho is there, Hunk, right? So Zoom charts. So we have the different charts are available. Jasper reports. Okay, we have the different reporting tools are there, right? So now once the data is available in SDFS, we are going to process the data in a MapReduce. After passing, we are generating some visualizations. Okay,
Mm-hmm.
right. Now
Yeah.
after performing the visualizations and after passing, now I want to store the data into the cluster. I don't want to send the data back to the Hadoop database. Sorry, your RDBMS. Okay, I want to store the data into the cluster. That is, I need a database in a cluster. Correct. Now, so
Okay.
after processing the data, if you want to store the data, we can able to store the data into the database. So in the Hadoop, we use a database called NoSQL. Okay, so NoSQL is a database because it's not SQL. Because in the Hadoop we are going to organize, we are going to process structured data as well as unstructured data. RDBMS is a structured, so can we able to store unstructured data into RDBMS? Not possible. Correct. So we are using
Yeah.
NoSQL.
Okay.
Okay, so NoSQL, what we have, HBase. So these are all the databases, MongoDB and
These
Cassandra.
are unstructured databases.
Yes, these are the NoSQL databases. You have to say NoSQL databases. Generally, we store the data into NoSQL databases for Hadoop cluster. So we have the different
Okay.
databases are available. That is DynamoDB, HBase, MongoDB, Cassandra. Right? These are the NoSQL databases. Now, if you want to store the
So
data,
what do you use in your company? We use HBase or MongoDB.
HBase. Generally, most of the people will prefer to use HBase.
Okay. And what take it what this do you use Hive, Pig, Java, or MapReduce?
It's now based upon the job which you're writing. You can use anyone which is which you are flexible. We can use Hive
No,
and
what do you use in your company, like
we
in your
use
work?
Hive. We use Hive.
Hive. Okay.
We use Hive and HBase together.
Okay.
Okay. Now see, then it's a NoSQL which we are going to store the data. Right now, see here, as a Hadoop developer, your job role will be in a data collection team, right? Which you are going to work with a database, sorry, which you are going to work with Scoop and Flume to collect the data into the Hadoop cluster, right? So this you have to write in your resume. So first, second interview question in your resume is how you are getting the data,
Okay.
right? Hi, Sindhuri.
Hi Ajay.
Yeah, sorry, I didn't see you, right? Okay, now so they are collecting the data. So the first question, the second question in interview, it's every interview they'll ask this question: how you're collecting the data, from where you're getting the data. So now either you are using a Flume or you are using a Scoop to collect the data into the Hadoop cluster, right? So this is what you have to do, right? So now once we have collected the data into the cluster, right? So now as a Hadoop developer, your job role will be in a data collection team where you have to collect the data from the, either it can be a database or the flow, right? Otherwise, if
Okay.
you are in a data processing team, then you have to write some programs in Hive or Peak or Java to process the data, right? As this is,
Okay.
as a Hadoop developer, your job role will becomes as like a Flume, right? A Scoop, Hive, Peak, Java. This comes as part of a Hadoop developer job role, right? So this you should know. Suppose if you are going as a Hadoop analyst, then you have to know the any one tool, right? Generally we use any one tool to analyze the data. So the Hadoop analyst role comes, with the Hive and Pig and Java to process it. And the most of the times you should know any one reporting visualization tool, right? So that's a W or quick view, Pentaho, right? So these are the visualization, so which is the role of Hadoop analyst. Okay, right. Now, we have separate NoSQL developers are available. See, if you are writing a Java program, or you are a Java programmer, then how much SQL we use? We use only DDL, DML commands, right? And if you want something write program, then that will be given to the PLSQL programmers, correct? So there is a separate PLSQL programmer and you're a Java programmer. So you should know like how to connect to the database through JDBC, how to retrieve the data from the database, right? We should know like DDL, DML commands, and we no need to know the programming, correct? The same way now, you being a Hadoop developer, you should know how to perform the CRUD operations, right? Like reading the data, updating the data, deleting the data, that you should know. That's it. And there is a separate HBase developer for HBase programming, and there is a MongoDB developer for MongoDB programming. Like Cassandra developer will be there for the Cassandra programming. Like each database will have, like we have SQL Server developer, Oracle developer, DB2 developer, right? Even a Java developer will also use SQL, but how much he use? He use only DDL and DML commands to connect the data, and whatever the data is required, he is getting the data to the its application and its processing, right? This same here, Hadoop developer, we should know as a Hadoop developer, you should know the CRUD operations, how to create, read, update, delete. Okay, got it, right? So this is a each individual will have the developers. Now, so there is a someone who is going to configure this cluster, right? So taking the machines, establishing a network between the machines, and monitoring the health of the cluster, right? So if the data node 1 goes down, should make the cluster up and run, should able to identify why jobs are running slow, why cluster is slow, right? So these are all the responsibility of a Hadoop admin, right? So one role we have Hadoop developer is there, and I can see Hadoop analyst is one role. Okay, then what we have?
Hadoop admin.
Yes, correct. We have Hadoop admin is one role, and then if you have a NoSQL developers is one role. Like it's a database load, right? So these are the different job loads. Apart from that, now we have some coordination should be done, right? All these components, right? So the coordination which we use a component called zookeeper. Okay, so these are all the coordinated by the zookeeper. Generally in a zoo, what zookeeper will do, right? Zookeeper will coordinate all the animals in a zoo, right? So here in the Hadoop, zookeeper is a one component, okay, which coordinates all the Hadoop components.
Is it like a language or a tool?
It's a tool, it's an application, right? It's a kind of programming. Generally we'll have a separate zookeeper developer will have, right?
Can you show it?
uh just a second, it's already started and running, because by default we'll get it. You write ZKS
Uh,
LI. Yes.
Ajay, Hadoop developers must know this now, NoSQL, HBase, Cassandra, and everything.
No, no. We should know only CRUD operations in during. So we no need to know the complete HBase programming MongoDB. Because see,
But
yes,
but the requirements. I mean, they are asking like Cassandra and everything should be. I mean,
not
like
complete.
people.
No, no. They will ask you. See, now what we are doing now, we are collecting the data from the from the where from your production database we are collecting the data to the SDFS. Generally how your client will have, so they'll collect the data from the client to HBase directly. I don't want to store the data into SDFS because of the security. Okay, so that every project right now they are asking HBase, right, where we are going to load the data and then we are getting the data to the Hive to process the data. Okay, right. So
Okay.
it's not everybody will use all the components. Some clients will use HBase, some clients will MongoDB. Like some people will use Oracle, some people will use SQL Server, some people will use MySQL, like that, correct? So here either they use HBase or they use MongoDB or they use Cassandra, anyone that database they use, right? So not everybody will
Okay.
use all the Hadoop all the right, all the NoSQL databases. Either your client is HBase, means you have to connect with Hive and HBase or SDFS to HBase.
Okay.
Okay, so generally what we'll do, so like this, we have create some table in Hive. After that, so we load the data into HBase. So this is how we'll do every day, right? So that this I'm going to teach you, right? My sessions are role based sessions. I'll teach you, right? So what are the roles as you have to do in every day? So they are, I'm going to teach you in my sessions, right? So this is, I'm going to teach you how you load the data to HBase using pig, right? How you load the data using Hive to HBase, right? So this I'll teach you in the that particular respective session when we are discussing about uh right, Hive or pig or HBase, right? So this is one of your job to do on every day, right? Generally everybody will have this kind of things. Okay, right. So now, so these are the
Okay.
databases.
So we can use any of the combination in this, like MapReduce to time MongoDB, Hive to Cassandra. Anything is possible, or like any
Yes, it's
restriction?
possible. Hive to Cassandra you can use. Hive and HBase is like
Hive to
yeah, Hive and HBase like Java and the database one, Oracle and Java and Oracle, right? So the process
okay,
is done
most
in Java.
complex.
Yeah, like most like that, Java, and database will be the database you're using Oracle. So here the data will be available in HBase and the programming can be written into the Hive.
So these are all for unstructured data database. NoSQL is something unstructured database,
Yes,
right?
these are all the unstructured databases.
Okay. So why is like the before one failed? Like why does database and this one fail due to like more data accumulating day by day, and like the processing time is going up, right?
Because all the time we don't use the databases because bulk data will not be getting processed in database, correct? Facebook, if
Yeah.
they won't use database Facebook because the data they're having huge amount of data. The database is having limitations. It's only you can able to store only structured data. How you store unstructured data into the database? No, correct.
Okay.
So because
Yeah.
if I'm collecting your browsing history, so what Amazon they will do, so they will collect all your browsing history. So today you'll access in from one laptop, tomorrow you'll use different machines you use, right? You are the only one user, but you have the three different user IDs and two mobile numbers and three addresses. So which one will be the primary key?
Yeah.
Correct. So in my Amazon, I'm having with the different values, multiple mobile numbers. I'm using. I'm using the three different uh, Gmail IDs. They will identify you. You take any you create any number of Gmail IDs, but they will identify
Okay.
you, right? Now,
Then
so
is the
in this case, where is a primary? It cannot be a structured data. Now, if they store your data, they won't store your data as a structured data because they won't send your data to the database. Now they'll move the data to a physical file, right? Will be stored into the server. Now whenever you want to process it, you have to get the data from the server to Hadoop cluster and apply the analytics. Yes, yes, Prithvi.
okay. In which year this was invented? Hadoop or this whole thing?
Yeah, it's generally, see, I told no, it's 2009 2010.
Okay.
Okay, so most of the implementation is started from 2011, right? So it's a 0.11 version we're having. That time even less people knows what is the Hadoop.
What is the first company to use Hadoop?
Hadoop is from Google.
Google used it first.
Yahoo. I've sent this to
Yeah. Okay.
right. So I think I have given the mail, right? So you'll get this as an attachment to your mail, Hadoop description. Right. See, I'll send it to you. Just go through this
Okay.
one. Right. So you'll get a
Okay.
right an attachment Hadoop description.
Sure.
Where it is.
Okay. You can send it after the class if you want.
Yes. Right. So they had just see what is a Hadoop, right? So before that, when it is started, who by whom started, so what they have achieved. So I just wrote a little bit notes on this. Just go to this one. Okay.
Yeah.
Right. You'll get this in a mail too. Okay. Now, so this is
Okay.
have every day. So now your job role will be in any one of this here. Okay, so generally what you have to write in your role, so we are collecting the data from the Hadoop RDBMS to Hadoop cluster. My job role in this project, or we are using a Flume to collect the data from the server, or sometimes what we'll do, we are using the HBase database and we load the data to the HBase. Either it can be from the Flume, or it can be from the database, or it can be from the WinSCP. So we are loading the data into the HBase. After that, we are passing the data with Hive. So this is how to tell. Got it? So any other
Yeah.
questions in this session?
No.
No, Ajay.
Right. Okay. So we have the Hadoop components. Like one is we use a Flume, right? So Flume is one component. So what it will do, Flume is a distributed, reliable and available service for moving large amount of data from the network attached storages to the Hadoop cluster. Okay, Flume is a component. So what we'll do in a Flume, will configure an agent. Okay, it's a program, right? A process, and will specify the source, and will specify the sync location, and will create a channel. Now this agent will resides in the server. This process resides in the server. As the data is coming to the server, this agent will collect the data and it will sync the data into the Hadoop cluster. So that component is a Flume. Okay, and then we use another component, Scoop. Right, we have the two versions are available, Scoop and Scoop 2. So generally everybody will use Scoop. Scoop 2 is the server side. It's set to implement it to develop, right? So what this Scoop will do, Scoop will import the data from the RDBMS to the Hadoop cluster. Okay, so they use the JDBC, Java database connectivity. Through JDBC you are going to connect to the RDBMS. Like, can you connect any RDBMS, like you can use Oracle, MySQL, SQL Server, DB2, Netezza, Teradata. So whatever the data it is, so we have to get the connector. So once we have to configure the connector, then this connector will connect to the database and it will import the data to the Hadoop cluster. So that component is a Scoop. Okay, so both Scoop 1 and Scoop 2 both performs importing the data to the Hadoop cluster. We can perform importing the data from the RDBMS to Hadoop, and we can perform export the data from the Hadoop cluster to RDBMS. We can able to perform both import and exporting the data between the SDFS and RDBMS using a component called Scoop. Okay, right. Then we have a H catalog. hcatalog is a component which we are used to store the metadata. Suppose I have some input data is available. Now I'm writing an Hive program, then I have to load the data into Hive. Again, the same data I want to write another program in Pig. That is again you have to load the data into Pig. So instead of that, we use hcatalog to load the metadata. Now once the data is available in hcatalog, then we can process the data directly with the Hive, and we can process the data with a Pig, right? So that component is a hcatalog. So what you have to remember, hcatalog is a component which is used to store the metadata. Okay, see, like,
Can you show that in the diagram where H data where H
see,
catalog really comes?
yes, right, I'll show you all these things when we are discussing about the relevant topics. As of now, see how we are going getting the data. The second I'll show you, I will introduce the environment too. Suppose here it's a we have metastore manager is there, right? Now so I want to create a table, or I want to load some data. So what we'll do, see, create a new table from file, right? We'll specify the table name, right? Now we'll load the data from like this, upload a file, right? I'm loading the data from the my documents. So this is what we are going to do with the hcatalog. Right, now the data will be uploaded into the
No,
SDFS. This is hcatalog.
no, I'm asking like
Right, now the data is available, right? So this is a hcatalog programming, that's it, completed. Now the data is available in the Hadoop cluster with a table name test. So this we are going to do. Now we can process this data in Hive, we can process this data in a Pig. Okay,
Ajay, so these are all are different tools that we use in Hadoop.
yes, these are the different components, individual components, and each component will have its own right responsibility. Right, it's like we can see Scoop only performs the data from the rdbms. Apart from that, we won't do anything with the Scoop, right? So based upon the job role which we are saying, we use only that specific components. So it's not meant that all the time we use all the components. Okay,
Yeah, okay, Ajay.
right, like this we, right, now see the data is loaded into the table, right? Click text, right? So create a table. Now see, this is hcatalog component, right? So this is how we load the data from your my documents to the Hadoop. Now it can be processed directly in Hive, it can be used directly in a Pig. Okay, so now test 71 is created. Okay, so it's a hcatalog. And
no, in
here,
this diagram,
in this diagram, we use in the data
yeah,
processing.
where H catalog will come in this.
Yes, here. So what we'll do now, so we before processing the data, right, before passing the data, what we'll do, we'll store the data into hcatalog, right? So from this hcatalog, Hive will collect the Hive and Pig will use the data from the hcatalog. Okay, so hcatalog. Now what we'll do, from this SDFS, we load the data into hcatalog. Okay, so once the data is available in hcatalog, that can be processed directly to the Hive or Pig. We can use two
Okay,
ways.
from HDFS we can't take it directly, so there
Now
is
it can
some
take
middle.
see, 1 second. Now suppose here Hive has to get the data from the, suppose I have a file, some test prod info is there. Okay, now what I have to do, I have to write some analytics. Then I wrote a program, I wrote program in Hive. Now first I have to load this data into the Hive table, correct? So after that
Yeah,
I'll write some select statements. Now
yeah,
completed. Now I am writing here another program in pig, right? Then again I have to load the data into pig table, pig relation, right? So I'm
Yeah,
taking some temporary table equal to, so now I want to load which data, again prod info. So here also I use prod info, I have loaded the data. Means same data I'm loading how many times now? Two
two
times.
times.
Before that it's available already in SDFS, right? Where you're multiple times you're processing loading the data, where you're using space in here, again your Hive is using, means your same data we are loading into the three different times, correct? So instead of that,
Yeah.
what I'll do now, I'll load this data into H catalog once, only once. Okay, so
Okay.
now here what we'll do, once the data is available in H catalog, then Hive you can use the data directly from the H catalog. We no need to load the data, right? Pig
Okay.
also uses the
Okay.
data from the H catalog, so we no need to load the data. Only
So
once we have to.
in
Yes.
order to load data into H catalog, is there something like commands as you told, like spook commands or flume commands, or
No, no, no,
H
no.
catalog?
It's H catalog. H catalog is you can use GUI like this. Today now I have
Okay.
loaded some data, right?
Okay, this is how we do it. Okay. Okay, all right.
Right. So now I have loaded the data into this location somewhere. User high warehouse in a directory test1 71. I have loaded file a1.csv. It's
Okay.
easy, right? Got it, Sindhuri?
Yes, yes, Ajay.
So that's like instead of individually loading the data each time, once we'll make the data available in H catalog. So Hive can directly use and Pig can use. So we manually we won't load into the Hive, we won't load the data into the Pig because we already loaded the data into H catalog. So Hive will take the data from the H catalog and Pig will take the data from the H catalog. Okay, so it's a one component. H catalog is a one component where we'll make the data available in H catalog, so that can be processed directly with Hive, can be processed directly with the Pig.
Or map reduce.
Yes, not MapReduce. MapReduce we have to give input data. MapReduce doesn't take directly from H catalog. Okay, so here MapReduce is a concept that you're writing in Hive is a MapReduce. You're writing a Pig is a MapReduce. You're writing a Java is a MapReduce. Right? I told no MapReduce is a concept. Oops is a concept where you can write
Okay.
oops in C++ and Java. MapReduce is a concept where you can implement in Java, C, Hive, Pig, C++. Now whatever you want to do, you can use, right?
Okay.
So in this one, Hive and Pig are the dedicated components from the Apache, right? Its own sub project. So that we'll maximum will prefer to analyze the data with Hive and Pig. Clear or any confusion here?
No.
Sindhuri yourself?
No confusion, Ajay.
Okay, right? So this is the reason we use a H catalog. Now Hue is a GUI. Hue is a one component which provides GUI, right? Suppose see this what we have seen. Can you able to see the Hue here? Generally,
Yeah.
to work with the Hive, what I will do, I'll type Hive. Then I'll get the Hive terminal. Okay. So now previously I have created a table that is the test 71, right? Now it's available in Hive. Select start from test 71. This is I'm going to do through the terminal. Okay. But what is the difficult here? Everything is not GUI. So the same thing in the Hue is a one component which provides GUI. Suppose if you want to work the pig, so this is a pig shell, right? So now here we'll write the pig programs. Pig programs can be written in a grunt shell. So these are all the terminals because command based. And see, uh, if you want to use the same thing through GUI, then we'll have a component called Hue. So just click on Hue. Right now, see if you click on Hive, so you'll get Hive shell. Okay, so it will help you. So Hive editor, GUI, it will provide you the GUI. So where you can take help if you don't know what to do, it will suggest you. Got it? Okay.
Uh, I
Yes.
didn't get this one, Ajay.
Okay. So generally we'll work with the terminal by writing the commands and programs. Okay.
Okay.
So suppose if you want to write a Hive program, then I have to write Hive program in a Hive terminal.
Okay.
Okay. So now suppose if you want to use GUI, graphical user interface, right? So that it's easy, you can able to write the program. Correct? So the GUI for the Hive is available through Hue.
Oh, okay. Instead of using this
Yes.
uh, terminal, you are going with the GUI.
Yes. Generally, you will work with a command line CMD. Suppose if you take CMD, you want to run with a notepad. Here, if you write a notepad, you will get notepad. Otherwise,
Yes,
just
yes.
go and click here. It's a GUI. Right now, you want to
Yes, yes.
use with a
Got it.
command mode or you want to use with a GUI. The same thing. Right? If you want to work the Hive
Yes.
program, take a terminal and write all the Hive. But here it won't help, right? So you have to remember everything. You have to type. Otherwise, you can use through GUI.
So, so every company uses this hue. We can do it either ways in every company, or like is it restricted?
Yeah, it can be configured. No need. It's easy and simple. We can able to configure. So, but the thing is,
Okay.
I always prefer to use and learn using terminal, right?
Why? Why?
Because terminal will make you practice more. Okay. So, right? Because see here now, if you want to type something, you can type like this. It will show you where is the error immediately. Select start from. Suppose you now type start something. Select start from EMP. Right, see immediately it will be displayed with some different color, so you can able to
Yeah.
identify immediately. Here it's advantage with the GUI.
So you will use GUI?
No, we use terminals because
Uh, Ajay, can you execute this one? I mean, keeping select proper.
see, okay, sure. Let me check the tables, show tables, which tables will having. So we have executed select start from test one, right? So the same thing
Yes.
here, we'll execute select start from test 7 1 and click execute. Okay, executed and it's output. Okay, it's a kind of GUI. Hue is a component which provides GUI, but it's like maybe all the clients won't have this Hue. Okay, so it's
So, but this is same as SQL developer only, right?
yes. If you are using Hive, it's same as SQL. Hive follows the syntax is similar like MySQL.
Okay.
Okay, but MySQL is a database. Hive is a not a database.
Okay.
Okay, so now we have pig is a kind of programming, which is like a script program. Hive is like a MySQL program, right? Which we use to process the data. Pig follows the syntax is similar like a script program. Hive follows the syntax is similar like MySQL. Okay, but Hive is not a database. But how we write a MySQL statements, the same way we write in Hive.
Okay.
Okay, so HBase is a NoSQL database where we are going to store the data, and Zookeeper is a one component which we use to coordinate all the Hadoop components. Right, that is a Zookeeper. And Uzi is a component which is used to schedule the job scheduling, right? So every day at evening, in night 12 o'clock, I have to run this job. So then what I'll do now, I'll schedule that job to run on specific interval. So that job scheduling can be done in Uzi. Okay, Uzi is a component which is used to schedule the jobs. Okay, so it's a small component. And where is one component where we can configure Hadoop in a cloud. Suppose if you want to use Hadoop with not in infrastructure, but you want to use Hadoop in a cloud, then we use where. Where is one component which helps you to configure Hadoop cluster into the cloud. Okay, then snappy is a compression. Like in Windows we have WinZip, WinRAR is a compression tools, right? Similarly, the Hadoop from the Cloudera, they use a compression method, snappy. Generally in the Linux we have snappy, deflate, uh, gunzip, lzo. So these are the different types of compression tools. Like in Windows we have WinZip, WinRAR, 7zip, right? The same way, so snappy is one compression tool, right? So we'll compress the data. Okay, and Mahot is a one component which is used to analyze the data generated by the machines. Okay, Mahot is a component which is used to analyze the data generated by the machines. Okay,
What about
Okay.
Hortonworks?
sorry,
What about Hortonworks? What about the Hortonworks
just a second.
after that?
Right now, so these are all the components which are available in the cloud era, right? The same, all these things will have in Hortonworks, right? I told no, the movie same, but the theater it is different. So them in the here also we have HBase, Hive, Peak, Tej, Zookeeper, Hue, right? Star and Uzi, right? Flume, Accumulo, Avro, Mohot, because different components are there, right? So the component generally we
Okay.
use it is same in Hortonworks, it's same in Cloudera, it is same in Mapper. So how you write a Hive in the
Okay.
Cloudera, the same we write in.
Hortonworks is like environment,
Yes, Hadoop
something like.
distribution, they will sell the Hadoop, right? Either you can use Hadoop from the
Okay.
Cloudera, you can use Hadoop from the Hortonworks. Maybe in the next session sometime I'll show you this one, Hadoop in
Yeah.
HTTP.
So
I'll show.
Cloudera is open source. So is Hortonworks as also
Cloudera is not
open
open
source or?
source. Cloudera is not open source. Hadoop from the Apache is a open source.
Okay.
Right? See, actually, initially it is a Hadoop from the Apache. They won't provide you the support. Correct? Then, so Hadoop is available from the vendors. The vendors are either it can be Cloudera, Hortonworks, and Mapper. So if you are using Hadoop from the Cloudera, then you are the client of Cloudera. So they'll configure the Hadoop cluster. They will give you the support. Okay.
Okay.
So these are all the different vendors, right?
Okay.
Like Windows, we have Linux, but these are all the operating systems, but it's a different one.
Okay. So Hadoop environment